Yo, what is going on, Algebra 1? It's your teacher, Mr. Lopez, coming at you with another digital lesson, Chapter 12. We're going to start off Chapter 12 today with probably my favorite thing to teach in this book, mainly because it's so easy. Chapter 12 is all about data. And data is actually super important because I don't know if you looked around, but pretty much everything around you requires data. Your cell phones, data. All right. The internet, data. All right. Marketing, data. All right. All of the ads that you guys see on Instagram and on the Snapchat and on the YouTube and on the Twitch or wherever you're looking at anything, pretty much using the internet at all, as data collected and kind of marketing targeted at you, the websites that you view and the Google searches that you make. All that information is just data. Another word for data is just information. And even if you are with your parents, driving, I don't know where you drive nowadays because we're in quarantine. Just for full disclosure, we're in the year 2020. We are quarantined right now. Can't really do anything. Can't really go anywhere. But if you drove out and you guys looked at whether you look at a billboard or you look at the side of a bus or you look at the big signs, the vinyl signs that companies are printing, or even like the window displays, like all of this stuff is marketing and is aimed at getting your attention, and it's using the colors and the pictures and the wording and the fonts all designed to keep your attention just so that you might buy whatever they are selling. So data is super important. So this chapter is pretty important because the chances are whatever job that you have in the future will deal with data. Whether you're a doctor, like right now, looking at all the COVID-19 cases, I guess depends on who you trust, but really there's data coming out every day. And within those numbers, there are real representations of human life or real representations of real situations that we have to deal with. So numbers mean more than just 2 plus 2 and finding the reciprocal of this fraction. When you start dealing with data, you start dealing with real life. And data is super important. So whatever you do in your life, you guys will probably be using data. And we're going to be talking about matrices. And I love this lesson because it's super easy. All right. This is just one way to organize data. All right. The whole chapter is not going to be like this, but there's one whole chapter in Algebra 2 that deals with matrices. And usually it's most people's favorite chapter, just so you guys know. So let's go ahead and look at this. Let's figure out, what are matrices? Well, matrices is a plural of the word matrix. And I know what you're thinking, but stop thinking that. It is not the movie, right? It is not. A matrix is a rectangular arrangement of numbers in rows and columns. Now, it's really important that you keep this idea in mind. Rows and columns, rows and columns. You want to keep it in that order. And okay, good. I just know what's coming your way in future math classes. So rows and columns, RC, Royal Crown, rows and columns. We want to make sure we keep that in that order. All right. So rows are the ones going horizontally and columns are the ones going vertically. If we take information, all right, we can put them in, if we take data, we can put them in what's called a matrix. So this is an example of a matrix. All right. And if you have plural, it is called matrices. Okay, so we're tracking so far. All right, if I wanted to identify the size of a matrix, I would go ahead and count the number of rows and then the number of columns. So looking at this matrix, this is known as a 2 by 2 matrix, right? Because there are 2 rows and then 2 columns. This guy right here is known as a 3 by 2 matrix because there are 3 rows, 1, 2, 3, and there are 2 columns. Rows and columns. Rows and columns. Cool? Now, Each number inside the matrix is known as an element. So right here, there are 4 elements, -1, 2, 4, and 0. These are all elements. And if you ever have an equal sign between them, these are known as equivalent matrices, meaning that these numbers have to equal the corresponding elements on the other side. -1 has to equal to -1. 2 has to equal to 4 over 2, which it does. They mean the same thing. 4 has to equal to 5 minus 1 because they're in the same spot, bottom left, and they are true, they are equivalent, and 0 is equal to 0. All right, so these are called equivalent matrices, and a matrix will always have the brackets around the outside. This is how we know that it is a matrix, and this data is put here for a very specific reason. So let's go ahead and look at these examples that I kind of made up. We're going to have practice with matrices, and here we have equivalent matrices. How do I know that they're equivalent? They have an equal sign. That means that these guys are equal. That means that the elements on this side, they match with the corresponding elements on this side. Now, let's go ahead and try to solve for what is the value of x and what is the value of y. Well, the first thing I'm going to do is I'm going to try to locate my value of x, any terms that have x in there. And I notice that there is an x right here, all right, and there are no other x's. So this x is equivalent with the x on this, or the same spot on the other side. This is in the top right corner, so it's going to match with this. So what does x equal? -5. That's not too bad, right? What if we had a problem that's looking for y? Want to solve for y? Well, y is right here. And what is a corresponding element that matches with y? Well, y is in the top left, and it matches with 1, so y is equal to 1. It's really not that scary, right? Equivalent matrices, not that scary. So let's go ahead and do another practice problem with equivalent matrices. Just so you guys know, this I don't think this was really covered on your homework, but this might end up on a quiz because I love these type of problems and they're really kind of easy. So just kind of giving you a heads up. All right, so I wanted to solve for x. So the first thing I'm going to do is I'm going to go ahead and look for any terms that have an x. I see that this guy has an x and there's no other x's. So now I'm going to figure out, well, what is the equivalent spot to it? So that means that I'm going to have 2x plus 1 is equal to 3. Okay? Now, how would I solve this? Well, I would subtract 1 on both sides. Equals 2. And then I get 2x is equal to 2. And then you divide. X equals 1. Alright? And how would I check my answer? Well, I can simply plug it in. Does 2 times 1 plus 1 equal 3? It sure does. I can do the same thing for y. I look for all the terms that have y and all of the corresponding elements that match it. So I would say that 2y is equal to 6. And I would simply solve this using regular algebra. And I get y is equal to 3. All right, so problems like this, you can see how the algebraic application. The important thing is that you understand that these guys are equal to each other. Now, what if you wanted to add matrices together? Well, you can add matrices together as long as they are the same dimensions. Like, can I add these two guys together? Well, this is 2 rows by 2 columns, 2 by 2, and 2 rows by 2 columns, so you can add them together. And addition and subtraction are going to work just like what you would think. Addition is a lot easier, and subtraction is one little key thing to pay attention to. So let's go ahead and add these together. I'm just going to go ahead and add the corresponding elements. -5 plus -3 is -8. 2.7 plus -3.9 is -1.2. And I could just use a calculator in order to add these together. And the bottom left, 7 plus -4 is the same thing as 3. And then -3 plus 2 is the same thing as -1. All I did was add them all together the way that they're supposed to. All right, so really nothing scary there. All right. So that was addition. What about subtraction? Well, here we have an example of a subtraction problem. It works very similarly to how you would expect it to work, so it's really not that confusing, not that tricky. But because it's subtraction, I'm going to advise that you are super careful about it, because subtraction can be tricky, especially when it comes to integers. So what I'm going to do is I'm going to go ahead and write this as a bigger matrix. I'm going to write this first one as -4 minus -5. Now, -4 minus -5 is the same thing as -4 plus 5, and -4 plus 5 is the same thing as 1. So be careful, because two negative signs make a positive sign, and -4 plus 5 equals 1. Then I just go ahead and do what is 0 minus -1. Well, two negative signs make a plus sign, so this is 0 plus 1, which is going to be 1. All right, not too bad. Now, as long as you're careful with that negative sign, this is 3 minus 0.5, which is going to be 2.5. That one's not even that tricky. I should probably write this a little bit more in line, because these are supposed to stay in rows and columns. And then let's do one more color. We have 7 minus -3. Two negative signs make a plus sign, so this is 7 plus 3, which is 10. So just be careful. I just want to remind you to be careful when it comes to subtracting, because that negative sign switches the sign. All right, cool? Cool. One of the last aspects that we need to talk about, at least when it comes to the very basics of matrix math, is multiplication, scalar multiplication. You can multiply matrices together, but there are very specific rules to that, and we're not going to cover that this year. Wait till Algebra 2 to give you something to look forward to. But when it comes to scalar multiplication, it is quite easy. And this is an example of scalar multiplication. I am multiplying a regular number multiplied by a matrix. And whenever you do that, this works just like distribution. Yay, something familiar. All right. If you guys want a refresher for a distribution, if I had 2 times x plus 5, you would distribute the 2 times every term on the inside, and I would get 2x plus 10. 2 times x is 2x. 2 times 5 is 10. Easy enough. Now, when we have scalar multiplication, we're going to distribute the number on the outside towards every element. So this would be 3 times 4 negative 1.5, 1 negative 6. And all I would do is distribute this to every single term. Whenever we use matrix multiplication or scalar multiplication, we would have the same dimensions when we multiply. So what is 3 times 4? 12. All right, what is 3 times negative 1.5? That'll be the same thing as negative 4.5. What is 3 times 1? 3. And what is 3 times negative 6? Negative 18. And this would be my answer. Really easy, matrix form, super simple. I love this stuff. I think it's really neat and really fun. Hope you guys like it too. So how would I multiply this number to this matrix? We would just go ahead and distribute. All right. I would get the same thing as negative 2 times negative 3 is positive 6. Negative 2 times 7.1 is negative 14.2. And negative 2 times 5 is negative 10. And this would be my answer as a matrix. Fun! Lastly, you can use matrices to compare and add and subtract data. Like here, they give you information for clear and cloudy days in 3 specific cities in 2 different times of the year. And they took this information and they put them into different matrices. All right, we have clear days and cloudy days for the different cities. If I wanted to figure out which city has the greatest average number of clear days, you would just go ahead and add the clear columns together. And it looks like 212 clear days is the most amount of clear days. So which city had the most? Well, Phoenix was the top one, and Phoenix had the most clear days, So therefore, Phoenix has the greatest average of clear days. Which one has the greatest cloudy days? It looks like it would be Portland. All right, you can add, you can subtract, you can do a lot of things with matrices. Yay! Matrices!